Welcome to another video on my ESP32 right here. Internet of Things device, in my case without Internet of Things, but with digital output, digital input, pulse modulation, ANSI C and a lot of other stuff. It drives an LED, 7-segment display, which is actually 7 LEDs, 8, but the 8th is a dot and I don't use it. An event microphone that is not attached, LCD, hidden here is an LDR, about that later. A keypad that is still unfortunately not really functioning, and a Visitechnic pulse modulation driven motor and a pulse modulation driven servo motor. So what's the status? Well, the last 2 or 3 times I have been focusing on the ESP-IDF toolchain, meaning that I don't program using the Arduino IDE, but I just use bare Linux and a program into Flash rather than random access memory. Not the way that I like it. I like to program in random access memory, but the toolchain goes to Flash, which is only writable for so many times. I don't know how many times, but it's not limitless, while random access memory is limitless. It works kind of. The motors are not really functioning, unfortunately, for some yet unknown reason. Then they do, then they don't. Then I am controlling the LED. That works. I am trying to read, and that was the last thing last time, the LDR right here. And there's a little problem with it, because apart from a little coding error that I made and solved, the value is still 0. So first thing I want to do is testing via the Arduino to see if the LDR gives a nice result, and if not, solve it, because I think it may have been the wiring. And if that works, I'm going to test it on the ESP-IDF. Then another thing is that if you program in random access memory and cut the power, then everything should be gone. That gave some weird results a few times. If you program in Flash, it should retain. And that is also a question, so why, if I put the power on, how can I make sure that Flash just functions? I have to find it out. That's for intro. Oh, of course, 4 probes for the oscilloscope. And let's see whatever works and whatever doesn't. So, software side, Arduino IDE, then the ESP-IDF toolchain, code and execution terminal, obviously camera on the circuits and oscilloscope. As said, first Arduino IDE. Let's see if and I still have to upload, so, which reminds me, I have to change to claim ownership. Of the USB, and that is in this case indeed 2. Otherwise I cannot upload. So let's name this tab USB. this is terminal or output, and this is code, so I know which one is which. Then tool, I need, yeah, that's correct. Not quite sure if this is correct, but I'll keep it this way. And this is not good, but I did last time because otherwise I could not upload and this was still running. Yeah, and that's about it, I think. So let's do it. Compiling. I didn't change anything of the code, so that should be alright. Uploading, very good, very nice. I can start serial terminal. There it goes. Start LCD test, which means that indeed this one is working. Takes a bit of time. Also for me it's not too clear that it is working well with the right letters, etc. It is. Ah, look at that. Which means this probe is doing nice work. This probe is that is strange. This probe should get voltage 3.3 volts, and so why is that happening? Alright, I'll have to check now, because I get strange signals. So this one should be, let's say, slope, and that is channel 2. I said 2. 3 should be a digital edge triggered, which looks like it, and 4 is also voltage, so that can be 4 as well. But this I don't understand. Oops. It should be 3.3 voltage and not a pulse like that one. So whatever this is, it is not what I expect. Apart from that, keypad no key, that's something else. But now, oh, LDR value is 256. In itself, that's good. It's not 0, and this is 0.2 volts. I'm fine with that, but LCD is stopped. Everything has stopped for some reason. Let's upload again. So I say upload, and it does compile. So does this go better? No, because the LCD is stuck. However, this one is functioning, this one is not. The motors don't do anything. LDR value gives a gives another different value. So let me put my finger on it, literally, and see whatever change that makes, if any. Same segment display works nicely. It's too bright for you to see. Now you can see. What difference does the LDR make? Okay, so LDR is functioning. That's good. Which means that I will now cut the power, stop this one, and go over to ESP-IDF to see if the LDR gives value now. If it doesn't, I have made probably a code error. So let's cut the power, and I'll do that not on the ESP side but on the other side. And there we go, off. Yep. Alright, second point, I am now going here, and the question is, how will it go, because it is still powered off. Now it's powered on. Does it do anything? No, it doesn't. So most likely I have to check for T2 USB 2. Yeah, I can't do anything now, which means I have to go here to make things easy, claim ownership, and now it does work. It's fine, and this USB 2, which is also fine. So now I can test it by, yeah, how? Make monitor. If that works out. Oh, look at this. The software in the random access memory is still operating. So much for volatile memory on with cut power. Okay, I am quitting this one. Yeah, LDR value is this, but that's not what I want. Quit. I will make flash. And then I wonder what is going to happen with the software. Okay, once again, make monitor. And this is, oh, now look at this, wait, I think I know the mistake I made. Because, okay, let's quit this. Can I? No, that is too far gone. If you remember, the LDR showed 2 for something or 4 something millivolts, which means it in the coder, and that is cheeky on C, This is only one thing. However, LDR is not an integer, and that is my mistake. LDR has to be floating point. Float with, and there it comes, this. So that also means floating point. I have to use here not a D but F, and also 1.3, which means 1 digit in front of the decimal and 3 behind it. And that will probably be much better and give me the value that I want. So, save, make flash. Alright, make monitor. See, and now it is still not alright. Now I do get what I like in output, but given the fact that with Arduino IDE monitor I get a nice value of 0.4 something or 0.3 something or 2 something, here it stays empty, which means that my input is not correct. So this can hold because it means nothing. I have to check on my input. Which input do I have to use? And last time I figured out that it had to be 36, and because VP turned out to be 36. However, if I go look at, take a look at this one, yeah, it's 36, and I have defined IO input IO 0 is pin 36. I know this should work because 5 and 15 are outputs, which already do work considering the fact that the LED and this one do work, despite not monitoring, but it does work. So then we have here input pin select is this one. That is alright. And then I come right here, auto pin select, input pin select. So I might have to consider the example again, because I have done now everything that should have been done. Alright, let's check that one. Right, some development and confusion. First of all, I found that with Arduino, the LDR, the light dependent resistor, which gives, depending on light, a voltage, or more appropriately, it is a resistor and depending on the light, the resistor allows a voltage to a voltage level to pass, which you can measure. But with ESP-IDF toolchain clearly doesn't work. Big question, why? Well, turns out in the schematics of the ESP, the port right here says VP, which can be anything, number 36. Right. So you can use that as input. More appropriately, input only. Alright, nothing wrong. I want to read the LDR. However, it's not just input only, it's digital input only. And there is problem with, because the LDR is anything but digital. So how can the LDR work nicely on a digital input only with Arduino and not with Arduino with the toolchain, since that value is 0, entirely 0? Well, because input 36 is an ADC, analog to digital converter, which apparently in the whole combination of Arduino IDE with ESP32 works flawlessly, but using the toolchain you have to set it and you have to sample it. So what I have done now is added an analog to digital converter and a calibration. Then I threw out the definition of GPIO input 36 as well as the general input pin selection. I have added things for the analog to digital channel, where I had of course to take care of the fact that they in the example use a different channel. My channel is, yes, GPIO 36, which is of analog to digital converter 1, which is channel 0 in my case. Then here everything of the input I can discard because it is no longer relevant. And here I am still with the old not working coder, which I still have to set. LDR I keep. In the example they use something different, very appropriately named voltage, which it is, but I use LDR to say okay, it's the voltage on the LDR, but the code still has to be set. So will that work? Well, it's a lot of code. Let's see if I can put it right here. So yes, I can apparently. And this, I think I can also do like this. If not, but yeah, I think I can. Although this is also nicely set to go like this, and then alright, something like this, and this is just one thing because there's more coming. But this shows that with Arduino IDE, where according to the information a lot more is possible than I thought, in the toolchain this is very low level. You have to define everything. So let me see if I can get things to work. And I need more code. Alright, final point or moments with this attempt. I copied a lot of this code from the GitHub, which gives free examples. So if you're looking for code like this, please look to ESP-IDF GitHub. And then ADC, and look to digital converter. And I removed and changed some stuff because I'm not using the ADC 2, I'm only using ADC 1. So I haven't tested it yet. So what happens here, and this is interesting, my own code I have commented out, which is, as I said earlier, into floating point. Now this roll and LDR voltage, and I put LDR in front of it myself, this is all unsigned integer. Integer being a number, ordinary number, unsigned. So ADC reading is unsigned integer, and and voltage, as you can see, is unsigned integer, so it's no floating point at all. Haven't compiled it yet, so that will be interesting. Compile and put to flash, and that's not going to work. Why? ISR is not going to do anything. Where is it? In 42. That is here. Yeah, because I used it for the conversion. So this can effectively go. 42. Yeah. And this is the whole part of the code, so I'm going once again back to 42. Integer, or insert I mean. And then here, end of block. Well, what else? Number of samples. Undeclared. The number of samples was in the other code. So I apparently, obviously, overlooked some of the code in the example, although number of samples. Well, I can only think that number of samples is just, oh yeah, right. Number of samples was set to 64, somewhere around here. Static number of samples. Yeah. So let's see how that is actually named. That was no of samples. Okay. Or define, because here it's like that. Static constant. No. Okay. Of samples 64. I think they did it like this. New try. Oh, and an implicit declaration. Well, yeah. Okay, I will. Okay, that is, I think, in 40. Yeah, that's this one. Has to go as well. Right. If this gives another error, yes, okay, I'll have to do it next time. Time is running out. But I'm one step further for LDR reading in ESP-IDF. So with the random access memory Arduino driven code still on the display, this is toolchain software and motor not running again. LDR under construction. I say thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up and leave a comment or suggestion. Very much appreciated. And you can also follow me via Instagram and Twitter. Please consider a donation via PayPal or Wired. And you can also become a patron, and depending on the pledge you make, may have your name mentioned. For more information, please see in the description box under this video. And well, this is obviously going to be continued. For now, have a nice day and bye bye.